Hey, how you doing? My name's Elton. Welcome to the show. Thank you for joining me. So the theme this month is all about observability, and for this week we're focusing on tracing. So tracing is this idea that you can record information in your applications about how long things take. So if you've got some heavily computational service that's compute intensive, you might record some information about when that processing starts and when it stops. So you can see that coming through. So when you're trying to understand the overall performance of your app, you can drill down into these different components. It's particularly applicable when you have a distributed application across many different components, which you get in your containerized microservice architecture, because everything's talking to each other. And that distributed tracing can tell you from the entry point when the user browses to your website, all the different services that get called as part of that transaction. So you can see where each part takes, what's being called, and you can kind of you can compose that call chain that the user doesn't see because they just see the application. You can see everything that goes in behind. Now, there's a fairly, like all things containery and everything we see in this show, there's a pretty established way of doing this now. And I'm going to show you a CNCF project called Jaeger, which is the kind of the main way of doing this tracing, recording the tracing that happens there. There's lots of different components to Jaeger. It does the collection and the storage, and there's some overlap when you're looking at tracing with the other things that we've seen in the observability space. So logging and metrics, they kind of blur some of the positions there. So we'll look at the sort of stuff you get from Jaeger, and then we'll see kind of how it works when you're running these things in Docker containers, and when you're looking at Kubernetes when you're moving into more of a production environment. So if you're new to the show, hello, my name's Elton. I'm a Docker captain and a Microsoft Azure MVP. I'm a consultant and trainer. I help people get their applications running in containers. The format of the show is always the same. So there's a quick kind of intro from me here telling you what you're going to see. Then I'm going to switch over to that screen. I'm going to be running demos for the whole rest of the show. While I do that, I'm going to move my microphone. I'm going to pull down my green screen. I've got like a 20-second advert to show you about all the other great stuff that I do while I do that stuff. And so I'll see you in just a second over there. You're watching Elton's Container Show with your host, that's me, Elton Stoneman. These shows are live, unscripted, and unrehearsed, so if you like my style but you prefer something a little more polished, then you should check out my courses on Pluralsight. Pluralsight's an online training platform, and I've got tons of video courses on there that you're bound to find useful. And if you prefer to learn by reading, then you'll be interested in my books, Learn Docker in a Month of Lunches and Learn Kubernetes in a Month of Lunches, which are both published by Manning. And if you just want to see what I'm up to, then you can check out my blog. And now, back to the show. Okay, that's better. Last week, this camera didn't work. I don't know why. It was some sort of weird setting. It has, let's not go into that. So now everything's looking good. So I've got my green screen behind me. So now we're going to stick to the script for the rest of the show. It's not scripted, so there is no script. But what I'm going to be looking at here, this is all up on GitHub. So everything that I do is all demo based. You don't need much to follow along. There's a prereq section for each show telling you what you need. You just need Docker Desktop or some other container runtime and some other version of Kubernetes if you want to try this out for yourself. There's a few links of what I'm going to be talking about in the show. I've got a whole new demo app that you haven't seen before. That has got these tracing bits built in. There's quite a bit of development work that you need to do, engineering work to record the things that you're interested in when it comes to tracing. So I've got a separate repo with that source code app. I'll show you a couple of things, but I appreciate this isn't really like a .NET show, so I'm not going to spend a whole bunch of time. I'll just show you what that stuff looks like. But if you are a .NET person, then you'll be pleased to know that my new Udemy course is available. So I've been teaching on Pluralsight for a long time, but I appreciate Pluralsight is like a monthly subscription, so a lot of people don't want to have that kind of commitment. So I've just launched my new course on Udemy, which goes to, if you go to Docker for .NET, you'll see there's a whole bunch of stuff in there with basically pictures of me. This is how the way I present this show is the way I present that course on Udemy, except that I cut out all the mistakes. So if you're interested in that, go up to Udemy. If you go to, let's go back to where I was there before, which is, I'm on Firefox. If I go back to Docker for .NET apps, if you go and look at this site here and click all these buttons, and eventually you'll get to the end there. And if you click on this button here, you'll always get the cheapest version. So if you go direct to Udemy, then it's a little bit more expensive. If you go for Docker for .NET/Udemy, it'll always be the cheapest. I like two ratings, 5 stars. Gotta be good. Okay, so let's get on with the show. If you skip through the advert, I got you there with the extra advert. So Jaeger is this thing that's going to be the collector. And it gives you a front end as well to show you the traces that are coming through. So it's kind of analogous to Prometheus, Whereas in Prometheus, in all of your application containers, you need to add this metrics endpoint, which exposes the data that you care about, and then Prometheus goes and pulls from them. Jaeger is more of a kind of traditional push model. So inside your application code, you'll be sending data to Jaeger. It's pretty lightweight. It uses UDP, so it's very kind of minimal network impact. And typically when you're in production, you'll just do like a sampling thing. So instead of sending every single trace to Jaeger, your Jaeger client library that you put inside your code will just pick up like one call in 1,000 or something like that, whatever you want to sample, and send that through to Jaeger. So you get, again, same as we get with Prometheus, what you're looking at is kind of trends and seeing how things perform over time. Okay, so let's go and have a look at this. So I've got this demo application that we're going to run. The first thing I'm going to do is just going to run Jaeger. So Jaeger itself is a distributed application. When you're running it in production, which we'll see at the end of the show, there's lots of different pieces. So Jaeger doesn't try to reinvent things. It can use Cassandra or Elasticsearch as the data store. It's got its own little UI component. It's got an agent component that collects collects is the wrong word, agent component that listens for incoming traces that come from your application components, and then a collector that goes and kind of collects all those things from the agents and stores them in the database. So it's all kind of distributed. It's quite complex product to deploy, but there's a Kubernetes operator for that. So we'll see what that looks like towards the end, which is how you'll do this stuff in production. But when you're not in production, you can use this image on Docker Hub, which is the all-in-one image. So it's just like the anti-pattern of how you build a distributed application and put everything in one container image, but it's fine for your non-production environments when you're just kind of poking around with Jaeger and you want to see how it looks. If you read a bunch of kind of getting started guides, they'll tell you to use that image, and they'll tell you to publish about 30 different ports without explaining what they do. If you're running in a fully containerized environment, of course, all of your containers will talk to the Jaeger container over the container network. So the only port you need to publish is this one, 16686, which is for the UI. Okay, so that's what I'm going to here. And the other thing I'm going to be running is my application, which is this new demo app. There's a Postgres database, there's a couple of backend services, and there's a website. So we'll see that in a second, but we'll start just with Jaeger. Okay, so let's open up my terminal here. So let's check I'm in the right place. Let's check this way. Yep. Okay. Cool. So this is all on GitHub. So every episode there's a folder with all the demos and stuff with the README document that I'm going to go through, and you can go through that yourself if you want to. So first thing we're going to do is just run Jaeger. So I'm pointing to that V1 demo application that's written in Docker Compose. I'm using Docker Compose to start just the Jaeger component. So I'm just going to have one container running here. If I do a Docker PS, I've got my Jaeger, and that's the port that's published. So if I browse to that port, localhost, this is the kind of standard Jaeger UI. There's a search which lets you search for all the traces. So this is connecting to the back end, which is the data store and all that sort of stuff. And there's also a query component, which is running like the API. Just like with Prometheus, you have Prometheus itself does the data storage. It gives you an API, it gives you a UI. You've got a similar thing with Jaeger, but they're broken down. Okay, so right now there are no services, but if I refresh, we'll see there is a service in here, which is the Jaeger query service, which is one of those components. If I click on find traces, there's a bunch of things already in here. So just like with Prometheus can instrument itself, Jaeger does the same thing. So the Jaeger query component is recording any requests that come in, and the Jaeger UI is talking to the query component. So behind the scenes, that's happening all the time already. So you'll always kind of see that stuff inside there. And this is what the traces look like. You can search for a particular trace by a service name or by an operation within that service. And then when you see these things, you can drill into them. And you get a whole bunch of tags that tell you kind of what's going on. There's not very much of interest in here. It's much more interesting when you're using your own application, so we'll come on to that next. Okay, so the Jaeger UI, pretty simple. Now, let's run the rest of the application here. So I'm going to start up the rest of my demo app. These are all pretty lightweight services and components, so it should all start up pretty quickly. We've got two backend services, so it's like a product website. There's one API that lists all the products that are available. There's another API that lists you the stock for each individual product. Everything's stored in a Postgres database. If I browse to 8081 products, this is there's my JSON response. So it's meant to be like a website, a bit like Primer only for building IoT applications. So those are the things that I've got here. This the products API just tells me the name of the product and the price. And then if I go and look at the stock API, I can give it a particular product ID, and I'll see how much stock we've got in there. So these are all running in separate containers. Inside the code for all these containers, there is tracing enabled, but I haven't turned it on yet for this deployment. So we'll just see, we kind of like iteratively build up what that distributed tracing looks like. Now go and check the application here. There it is, Widgetario. That's my logo for the company that I designed myself. So you can see this stuff is coming from the products API, and there's code behind there to say if this goes to the stock API as well. If there is no stock, then we don't show it. So like, very, very simple. 3 different components. They're all written in .NET Core just because that's my kind of main programming language. All the source code's around, so you can go and check it out. Each of these has integration with Jaeger using the client libraries. And again, it's similar to what you do with Prometheus. Prometheus, you bring that client library into your application, you record the metrics that you care about. With Jaeger, you bring in the Jaeger tracing Jaeger tracing client library, and you do something similar. So we'll have a quick look at the code, but I'm not going to spend too much time in there. For all of the main languages, Go, Java, Node.js, Python, they've all got a client library, and they all integrate with the hosting platform in some way. So what I've got here is my .NET application. This is the website. So the client library gives me all this stuff here. So there's a kind of split between the Jaeger component itself and the kind of broader open standard called OpenTelemetry. So OpenTelemetry defines what the API looks like when you're capturing the data and sending it to some sort of collector, and Jaeger is the collector. So there's a combination of the two things here. So what I'm doing here is I'm building up this reporter that's going to send data to Jaeger. It's going to get from my configuration to find out what the name of the service is to send it to, and then I've got this tracer component that is going to use that reporter and the sampler. And the sampler is a really simple one that just says we're going to sample every single call. So you wouldn't have that in production, obviously, and you would make this all configurable so you can add that stuff in there. With ASP.NET here, I've got dependency injection, which is also supported in that client library. So with this line here, services.add OpenTracing, that's going to give me a whole bunch of tracing for free. Just like with Prometheus, when you add those client libraries, you get a bunch of runtime information for free, like CPU usage, memory usage, how long it takes for an HTTP call if it's a web platform. Just the same with the Jaeger client libraries and the OpenTelemetry client libraries. This knows how ASP.NET works, and it's going to hook into the pipeline, which goes and gets content when an HTTP request comes in and sends it back out. So I will get some tracing for free. But I've also got custom tracing in here. So if I look at this controller class here, this is what happens when you browse to the website. This index method gets called, and that just goes and fetches all the data from my API. So the fetching happens here, like await product service, get products, await stock service, get the stock for the product ID. But these are wrapped up inside these scopes, which are doing my tracing for me. So I'm saying build a span, build a scope called API load, and then that's going to time how long all the data fetching takes. And if I go and look at this here, I'm also within there, I'm got a separate span to go to the product API and another span to go to the stock API. So I've manually put these bits in here. So imagine this was either computationally heavy or making a lot of external requests, and I want to be able to trace down to a very fine-grained level. So by adding this stuff here, I'm kind of manually recording the spans that I'm interested in, the traces that I want to record. Okay, so what we've got here is if I go and look at the logging for this website here, so if I do a Docker container log, so we saw also in that code, there's just a really basic entry inside here that says, just writing a log entry to say loading products to stock. That happens at the beginning, and then we go and call all those APIs, and then at the end we say product and stock loads took whatever. So there's just some logging code in there that's manually collecting the amount of time it takes and writing it out, which is never any good except for in development when you're debugging to see what's going on. This is why you would move from this kind of model to a tracing model where you have those spans in there, because that lets you aggregate across all of your containers. It gives you a single place where you can see what's going on, and then drill down within that to see how long an individual trace takes for one particular user or one class of users, and then average out across all that stuff. So as you're looking at observability, and as I've said, there is a kind of blur about where these things land and where you want to put things as a log entry or as a metric in Prometheus or as a trace in Jaeger. Think about the other side of it. Think about where you need to get that information and what you want to get from it. So the tracing side is going to show you the dependencies for external things that your application calls into, or compute intensive stuff, things you might want to optimize, or things where you might need to understand something is broken further down the line. Okay, so my log entries are there, but that's not much good. So if I go now back to Jaeger, so my Widgetario app, just do a refresh here. If I go back to the Jaeger UI and refresh this, so I've got another service here. I've got my Widgetario.web. That's what when the application inside the client library, when you configure it, you give your service a name. That's what shows up here. And And then these operations are all the bits that are being collected as traces within that application. So I've got the custom things there, my API load, my product API load, but I also get the stuff for free. So this action here is the thing that that gets triggered when you make an HTTP request. So by integrating the client library with the runtime, with the pipeline to generate requests and responses, then I get all this stuff for free. So if I go and look at those actions there, those operations, if I find the traces, I'll see there are a few inside here. If I click on this one here, so you'll see there's a kind of breakdown of what's happening inside there. So first of all, I've got my HTTP GET request, and in total that took 83 milliseconds. So all this stuff is a kind of span of what's happening, drilling down inside that request. So the next thing down, after my initial HTTP GET, this calls into my controller class, which calls into the index component. And then inside there, I've got this span, my API load. Now I'm manually recording this, and I can record kind of anything I wanted to inside there. As part of this, your Jaeger component can connect in with your logging framework, and you can see some of the logs that pertain to that particular span that you're interested in. So when logs get written during that scope, they can be surfaced here in the Jaeger UI. So I can see there's my product and stock load took 72 milliseconds that I'm showing from my log entry, and then in the span that's been collected, it's 72 milliseconds. So I'm seeing that there's a correlation there, so that's good. But the thing that I really care about is the drilling down. So there's my product API load there, and I can see there's an HTTP GET request. That's an outgoing request. So this overall span is been triggered by the incoming request from a user who browsed to the website. But here there's an outgoing request, so I can see it's HTTP out. I can see all the interesting stuff here. So I can check the URL of the destination, which is my product API running in a different container. I can see the response code that I got was 200, and I can find out the information about the name of the host that I went to and all that sort of stuff. It gives me the host name, which is the container ID, obviously, because I'm running in containers, and it tells me which part of the client library collected this stuff. So I can see here that my call to my product API took 43 milliseconds, and then if I close this up and go down again, then I can see I make 3 calls to the stock API. So in my stock API load here, I've got a request for stock API / stock 1, and then there's going to be another one for stock 2, and then another one for stock 3. So I can see a drill down of everything that's happening inside my application, but I'm only seeing the client side here. I'm only seeing the fact that inside my web component, I've added all that tracing, and that's recording what's happening from within the web component. It doesn't attach to further on down the chain. We'll see how to do that in just a second. But I can see here, this is, there's useful stuff here as part of the development lifecycle and the architectural lifecycle, as well as the ongoing kind of production support. Because here I can see I make one call to the products API, and that's going to give me back all my products. And then for each product, I make a separate call to the stock API to get the stock for that individual product, which is obviously kind of non-optimal. It would be nicer to maybe go and fetch them all, or batch them up in some way, or have paging, or have caching. Lots of other options. I've done it in a really simple way just to show you how this stuff kind of fits together. So I've got this kind of interesting level of detail, but I'm only seeing things from my web component's point of view. I'm not tying it into what happens down the line, but I have got that code inside my application using the same client libraries for .NET Core, and they're integrating with my APIs, my backend services, so I can turn those tracing components on, and we'll see what we get when we get to the full picture. Okay, so let's close this down in a second. So we've seen all that stuff. Oh, the other thing is that Jaeger will give me a dependency graph. So this is the Jaeger UI. If I look at the system architecture here, there's nothing in there because it only knows about one component. What's happening behind the scenes when you make these tracing requests is that Jaeger gives everything a kind of unique ID. So we'll see this unique ID here. This is part of it here, and that gets recorded as part of your span, your trace that you're recording. And when you make a call to a separate component, that can be included inside the HTTP headers of the GET request. And then in that dependent component, if that's also enabled to do the tracing, it will take that unique ID that's coming in the header, and when it sends its traces to Jaeger, it will use the same ID. And so that's how everything kind of gets brought in together, because you've got this kind of unique ID at the top of the entry point of your application, and then that gets passed on to all the dependent services. So when they're recording their traces, everything gets linked together, so you can identify a unique transaction within the workflow of your application. So when we go and look to the downstream applications, we'll see that we'll be able to build out that dependency list, because Jaeger understands how the entry point to my application here calls into the other components. Okay, so let's go back here. I've got my distributed tracing already set up. If I look at the V2 spec here, and go and see what's happening. So it's the same definition. So Jaeger hasn't changed. My product database hasn't changed. My web component hasn't changed. That already had this feature flag to turn tracing on. That's why I saw that those top level details. And all I've got is in my other components, in my product API, and my stock API. I've turned tracing on for those two. So all that code is already in there. I'm not going to kind of do that now. So all that stuff's been built in, but it looks exactly the same. So I use the client library, I integrate it so that so I can see the traces that are coming through. I don't need to do anything else. So for my stock API, if I look at the source code here, for my website, I've got these kind of manual traces. But if I go and look at, say, the stock API here, I've got different versions. But the .NET version is the one we're looking at. If I go and look at the startup here, I've got pretty much the same code to plug in my OpenTelemetry recording and my Jaeger reporter. So I've got the same code in there, and there's no other code. So I'm not manually recording the fact when somebody comes into my controller here to fetch the stock details. There's nothing to do with telemetry inside here. So everything's being kind of set up for me as part of that client library, which is the same for all the other languages that have support for Jaeger and for OpenTelemetry. Okay, so I've got these little feature flags to turn that stuff on. So when I do my deployment, so let's clear the screen here and get some space. If I start up my V2, so what we'll see is that the website doesn't change and the database doesn't change because none of those definitions have changed. But we're going to recreate the product API and the stock API just because that config setting has changed. If you're confused about why that's happened, then that's an environment setting. The environment variables of a container have a part of that environment that Docker sets up. You can't change that once a container is created. You've got to replace it, which is what Compose is doing for me there. Okay, so now if I go back to my application again here, and go back to my Widgetario website and refresh. It's going to look exactly the same. It's going to go and call over to my my downstream components, my stock API. The behavior is the same. All that we've got is in the back end there. We've got tracing enabled throughout the stack now. So if I go to the Jaeger UI, and let's just scroll down a little bit here and find the most recent traces. So now we can see that I've got the same kind of thing here. I've got my Widgetario web. I've got the HTTP GET, which initiated that trace. I've got the unique ID for that trace, but here I've got all those different components. So now they're all sending their data to Jaeger, and they're all using that top level like unique ID, that correlation ID, to say that this call for the stock API was actually initiated by the website as part of this transaction. So if we look down here, I refreshed a couple of times. This one took 4 seconds because the components were starting up. So when I did my Docker Compose up, I got new containers, small kind of warm up time for them to happen, and we can see that here. So these took 4 seconds. And now I've got that level of detail that I had before, which is that my Widgetario website made a call to the product API. But underneath here now, I'm getting the data from the product API. So the product API here, I can see that this was my tags in the client call say that this was a client call. So we know that this was initiating an HTTP request. And if I scroll down and look at my server, I can see that this is coming from my product API. This is a response to that request. So this chunk of timing is about building up the response. And inside here, because of my my architecture, I'm using .NET Core. I'm using Entity Framework, which is an object relational mapper to go and get stuff from the database, and that's all standard stuff. So as well as being able to tell me that a request has come in for this particular API, this particular endpoint in my HTTP service, the client library, the Jaeger client library, can integrate with my database component, and it gives me a timing for the database queries that I make. So I'm not doing anything clever here. Like I've got my Postgres database, I've got my entity framework, I've got my ASP.NET Core, which is my REST API. I've added in the Jaeger client library, and it's found out everything for me. So it's integrated itself with all of my HTTP request endpoints. And because it knows that I've got entity framework inside there, which is the database component, it integrates with that too. And it tells me really cool stuff like inside here, inside the tags, it's telling me that it's going to talk to Postgres. And that's the SQL statement that it's going to execute. So again, if I get some really useful detail here without having to do a whole bunch of work, I can drill down to see my website called to my product API, and my product API made this database query here. That took a lot longer than I thought, so I can hand that over to the DBA so you can optimize it or put indexes in or whatever. So I get that level of detail there just from adding my Jaeger support. And then if I drill down inside here, then here's where I give my stock API load. And again, just like before, I've got the HTTP GET from the client side, which is the website making the call to the stock service. But then I've also now got the stock API side of things. So I can see that this is the server response that took 1.9 seconds. And the majority of that is it starting up. So, it's just that whole ASP.NET framework starting up down inside here. Again, because I'm using the same technology stack, I've got the same thing. So I can see from my stock that I've got this is entity framework core. That's the name of the component. Here's the statement that got executed. I can see that took 10 milliseconds. So, I'm not going to send this to a DBA because I don't have a performance problem. The biggest thing here is the startup time. So, that's something I can maybe feed in. And if I go back to my Jaeger UI and look at the next one that I made, so this is the next call when I refresh the website, it's 113 milliseconds this time. So I can see at the top level here, the where the time's going. So from the user clicking the button to getting their response back, or having generated the response and sent it on, because we don't see from the end user's point of view here. That took 113 milliseconds. 50 of that was going to the product API, and 20 of it was going to the stock API, even though the stock API made 3 separate calls. So I can see, there's 120, 115, and 112. So I can see that kind of overall time. I spent 50 milliseconds there. And we can see that these are not parallelized. So my calls to the stock API are happening in series. So, there are definite options for optimization there. And if I was having a database problem, I can decide with this level of detail. This is my distributed tracing that tells me exactly what's going on across all my components, website, backend service, and database. Where is it best for me to do my tuning? If I did have a performance problem, do I put caching in the website? Well, this will give me the breakdown of whether that's useful, or whether I should put caching in my API, or whether I should optimize my database queries or my table structure. So I've got a whole lot of detail here with actually kind of very little input from a coding point of view. Okay, so let's go and have a look at how we do what the optimization looks like. So if I now go and look at version 3 of my deployment, and all I've done inside here is inside my stock API, which is the one that the website calls multiple times. I've got some caching that I can turn on inside that component, so it won't go to the database every time. It goes to the database the first time, caches all the stock, and then sends it back as while that cache is alive for 5 minutes. So all this is going to do is replace my stock API component, my stock service, with a new version that turns on caching. So let's do that. Let's close that down just to show you how the tracing changes, what you see from that, and how this can, if you're doing these sorts of communication changes to work out how the endpoints in your application are going to be serviced, and where you're going to do some optimization to make sure things are behaving the way you expect them to. So let's go back to my website here, my Widgetario website, and we're going to do a couple of refreshes. So the first one will be a bit slow because it's brand new stock API container. Second time will be faster. Let's go back to my Jaeger UI. And again, let's have a look here and find the new traces. So, okay, so here's the thing that we're seeing here. So originally, when I made my widgetario.web call, there are 12 traces within that span. So there are 12 operations that are being recorded, and that there are also 12 calls to the stock API. The next time there are 12 to the website and 10 to the stock API, and then there are 12 to the website and 9 to the stock API. So I can see there's something happening there. There's not as much information being recorded, and I'm kind of hoping that's because things are being cached. So I go and look at this one that's got 10. If I scroll all the way down here, I can see there's still 3 HTTP GET requests to the stock API. There's my execute reader, which happens here. There's my database call that goes and fetches all the stock this time, and then subsequent calls, there are no database calls. So everything's now coming from the memory store inside the stock API. So I've done some caching, and if this component was taking a long time to go and get data from the database, I would see a massive improvement now, and I would see that in the spans. I would see that in the tracing. So ultimately, my website would return faster, but I know that's because I've optimized the bit that needed optimizing. You can also see here in the logs that I'm using this component called easy caching, and easy caching is telling me that because that span is recording the logs that happen within that chunk of code, any logs that easy caching writes get recorded inside here and surfaced inside here too. So if I go and look at my stock API, my result object here, there's a whole bunch of logs telling me that easy caching is doing the writing. So it's storing the stuff inside memory. So it goes and gets it from the database, stores it inside memory, and then it doesn't call the database again. So I don't see those subsequent traces. So if I go back and look at this one that only had 9 calls, we'll see down here, there are no database actions. So that DB execute reader, that's all gone because I've optimized that out. So now I just see those traces that are happening there. So it's really this kind of overall holistic view that you can drill down, see what's going on here. And of course, here now I get my system architecture. That's it. If you look at the graph there, so I can see that I'm making these sorts of calls to my stock API and to my product API. So the optimization that I've done is at the level of that stock service. The website is still making multiple calls, so again, I could potentially optimize there. And the information that I'm getting from Jaeger will tell me whether it's worthwhile doing that or whether I should tie that into to some more optimization at a different level. Okay, so that's the kind of basis of it. Of course, you can work out all sorts of interesting things that you do here. It's not just a single workflow. When you've got like multiple entry points to your application, then you can model out those workflows, and you will see them all there. You can compare different traces over time, and you can work out what's happening as you implement performance optimizations or whatever else it is that you want to do. Okay, but what we've got so far with that, I'm trying to close my terminal. There we go. What we've got so far with that all-in-one Jaeger component, that's not how you're going to deploy things in reality. Like the whole point of this is that it's all scalable and it should be production quality. So the Jaeger team have this operator to deploy to Kubernetes. If you're not familiar with the operator idea, that it's just a way of wrapping up and installing complex software. So the people who build the software are the ones best known to how to deploy it. And so they wrap up this thing called an operator. So you define your own resource to say, I want some Jaeger, and the operator creates all the dependent components for you. So the Jaeger operator there is a proper production level thing. It expects you to have an Ingress controller and all sorts of stuff like that. But of course, being Kubernetes, you can still run that inside your local environment. So let's close this down here and just check that I've got I'm connected to the right cluster, because I don't want to take my blog offline, which I've done before. Okay, so I'm connected to Docker Desktop. Let's have a look at my namespaces. Nothing there. And let's just see there's nothing running. Okay, cool. So pretty much a kind of empty reset version of Kubernetes. So let's go and have a look at, I'm going to deploy my Ingress controller. I've talked about this in previous episodes, so I'm not going to spend any time on that. That's just my kind of routing component. That goes to its own custom namespace. So let's just check everything is running. So I've got my Nginx controller pods there. I've got my service. I've got my deployment. Yeah, all looking good. Everything is up and running. Now I'm going to deploy the Jaeger operator. So it's all available through their GitHub site. I've taken a copy of those YAML files, so I can kind of snapshot it here as part of the repo for today's episode. So I'm going to deploy the custom resource definition. Again, if you're not super familiar with Kubernetes, it's a very powerful system. It lets you it lets people who are building complex software extend Kubernetes with new types of things. So Kubernetes understands things of its own, like a pod is something that runs containers. You can define your own type of resource, your own entity, and that's exactly what happens here. So as part of the Jaeger operator, it defines a thing called a Jaeger, and then you can create that yourself. So that's just defining the custom resources, and then I can deploy the rest of the operator, which creates a whole bunch of stuff inside there. And now I can go and create my Jaeger instance. So this isn't giving me my own Jaeger deployment yet. It's setting up all the infrastructure to create, so I can create my own Jaeger. So let's close the terminal and have a look at how you define that. And that's about as simple as it gets. So what the operator gives me is this type of object called a Jaeger object. And so I'm creating my own Jaeger object. This is where I put all the definition that I wanted to have in there. So what type of database I want to use, whether I want to connect to an existing Elasticsearch database that I'm using for logging. There's a whole ton of options that you put in here. But if you leave it empty, you just get a fairly kind of vanilla, perfectly usable Jaeger instance that you can deploy in your environment. So let's close that down. Open this up again, get me some space. So I'm going to deploy my Jaeger definition. And what that's going to do is, I'm just running the default namespace here, so I'm not ordinarily you would isolate this and have it as a kind of subsystem for all of your components, but I'm just running it in the default namespace to make life easier. So that gives me a whole bunch of stuff. I've got my agent, which is the thing that's listening for incoming data, the collector that deals with that and sends it on to the storage. I've got some metrics. I've got the query component, which is where that serves the UI, and then I've got my UI running somewhere in there as well. Where's that? There we are. Oh, that's part of the UI. Okay, and then I'm also going to see if I look at my Ingress. Let's clear this down. I've got my Ingress rule here, so just for the local host, port 80, so standard kind of integration. My Nginx is listening on port 80, and anything that goes to local host, I don't have any host names in there, so Jaeger will give everything there. So previously I was running everything in Docker containers with Docker Compose. Same stack now, but now it's running in Kubernetes. And just like before, there's nothing to start with. But if I refresh, then we'll see the Jaeger queries recording its own traces. So that's now running in my Kubernetes cluster. So now I can deploy my application again. So let's clear this down. And just to show you, there's nothing particularly interesting in that definition. All this stuff is in the GitHub repo. If I look at the Widgetario, I've got my products API. I'm using the same Docker image that I was using before, and I've got those same environment variable to enable tracing. This time I'm specifying the name of the Jaeger service. Previously, I was just calling that Jaeger when everything was running in that all-in-one container image. Now that everything's been split out, I need to talk specifically to the agent. That's what I've got inside there. And everything's the same for all of my components. So everything's working the same way. The only thing that's different for the website is I'm using Ingress, and I've got a host name set up locally on my machine so that widgetario.local gets resolved and sent to my web component there. Okay, so nothing particularly clever there. So let's get rid of this. I can find all the right shortcuts. And let's deploy the Widgetario app. Okay, so that's a whole bunch of stuff looking there. Look at my pods. So I've got my Jaeger operator pod. That's the thing that's waiting to see if you want a new Jaeger created. And then I've got Jaeger itself up and running. I've got now my application components, the products API, database, all those bits and pieces. If I look at the Ingress rules, then I've got my Jaeger Ingress, and I've got my widgetario.local. So I should be able to browse to my web application here, widgetario.local, and hopefully that will all just work. It's connecting to the APIs at the back end, so they're all brand new containers running in pods with services between them. So that's why it took a few seconds. If I refresh, it'll all work in the same way. Go to the Jaeger UI and refresh, and we'll see I've got all these services. So everything's flowing through in the same way as before. I can go and look at my operation from my home page and find all those traces. And we'll see that everything works in the same way. I've got caching turned on, which is why we're seeing that these the calls to the stock API don't make any database calls, but everything works in the same way. So now, when I'm running with my production grade Kubernetes operator, I'm getting the same experience. I'm getting the same kind of data coming through, and it works as I scale things up. So as I'm running multiple instances of my API services and my website and all that sort of stuff, when I skip out to use a third-party database service, I'm still getting that tracing across all the clients that I'm getting inside here. So I've got let's go have a look at my product API. So the product API makes my call to Postgres. So I can see it goes and selects all the data. And then for my stock API, there is no database call because that's already happened previously from when I refreshed everything. Okay, so that's looking good. So the original goal for these episodes was to be sort of 30-40 minutes. So actually I'm on time today. Usually I tend to go a bit further up. Okay, there's a lot of stuff here. If you're following on, then there's a whole bunch of stuff that's been deployed. There's the Ingress controller, there's the Jaeger operator, there's Jaeger itself, there's the application. If you're running Docker desktop, the easiest way to tear everything down is to hit that reset Kubernetes button, which is what I tend to do before every episode. And that's a kind of whistle-stop tour of Jaeger. One of the interesting things about Jaeger, which I was going to talk about if I had time, is this kind of split between Jaeger itself and OpenTelemetry, which is also the case with Prometheus. So what happened in the kind of history of these things is that there was obviously a need to get these levels of observability into your containers, and a product emerged that solved that need and got really popular. So Prometheus for metrics, Jaeger for tracing. And then people get kind of nervy if there's only one product that everybody uses. So there was a motion to kind of spin out how those things operate at an open standard level. So OpenTracing was the first attempt to do that, and that merged into OpenTelemetry. And the idea there is to take things like the Prometheus exposition format, so the text format that you get when you browse to /metrics and you're looking at Prometheus, and to look at the Jaeger like the HTTP headers and all that sort of stuff that you collect when you're transferring in between your different components, to standardize those things. That's what OpenTelemetry is trying to do. So OpenTelemetry says, you can use the OpenTelemetry client libraries rather than a custom Prometheus client library or a Jaeger client library. Because, if you want to swap out the back end of your observability stack, like, that's one thing. But changing all of the client components, that's a much bigger effort. So the idea of OpenTelemetry is that I can have all these client libraries that are generic. They use the OpenTelemetry standards to expose metrics and to send and collect tracing information. And then in the back end, I may be using my OpenTelemetry client libraries to talk to Jaeger, and my OpenTelemetry client libraries to talk to have my Prometheus endpoint, the Prometheus is going to use, but I could swap out the backend if I wanted to. So that's been in kind of it's a CNCF project. It's been kind of working for a little while. It hasn't really taken off as yet, as far as I can see. So I think it's as opposed to Jaeger itself, which is a graduated project. This is still very much a work in progress. But the idea is there to separate out the standards of how you communicate with the back end, so that it's not just Jaeger and Prometheus. You've got the option to swap out into something different. Okay, and then the one thing about today's episode, which is different from what we usually do here. Oh, I'm looking at the wrong screen. This is the screen I was going to look at. Is there's a bit of source code. I don't usually show much source code because it's kind of dependent on what platforms you're used to and what languages you're using. And the fact of having to integrate all these client libraries kind of has quite a high entry barrier for what you want to do with your observability. So it'd be a lot nicer if you didn't have to do these chunks of stuff inside here. And that's true of the other parts of observability that I've talked about in this month's episode. So, logging, you need to make sure your logs are coming out from the standard output stream so that Docker can see them and Kubernetes can see them. Metrics, you need to expose those kind of metrics endpoints so that Prometheus gets there. And then if you want to do your tracing, you need to kind of put this code inside your application to host all those collectors that send that stuff off to Jaeger. What we're going to look at next week is doing that without changing a whole bunch of code. So taking advantage of the fact that Kubernetes lets you run multiple containers inside a single pod. So I can run my application container without having to change a bunch of code to integrate with other things. I can have additional containers that give me those observability endpoints that I need. So I could have a metrics exporter from Prometheus. I can have some sort of sidecar that's getting my logs out, all that sort of stuff. So we'll look at that next week. Observability with sidecar containers, and then that will lead us into next month when we're going to be talking about service mesh. So these are kind of gradual pieces that when we look at sidecars, you'll understand how all these things fit together, how you can add observability without rewriting your application. And then next month, when we look at service mesh, we'll look at the features that the service mesh gives you, but you'll understand how all that stuff works because you've seen all the individual pieces. So we're very low on chat today. There's not any questions coming in, which could be because my chat client isn't connected, but it seems to be connected. So hopefully you all found that really interesting. Thank you very much for watching. I'll see you again next week for the container show, finishing off the themes of observability, talking about how you can add observability to applications that don't do it natively with sidecar containers in Kubernetes.